All right, welcome back. Over the next couple of videos, we're going to take a look at user authentication. Now, this video is specifically going to take a look at registering a user. So we're going to do a couple different things. We're going to make sure that the username and password criteria are satisfied. We're going to go ahead and check and make sure we don't have a user by that name in the database already. And if we don't, then we're going to go ahead and take the password, create a hash for it, and then save that username and hash in the database. Now, if you're wondering why we're using a hash, go ahead and take a look at my video why companies don't save your password, or at least why they shouldn't. That explains it in much more detail. And finally, we're not going to go into email validation in this one. We're going to go ahead and cover that one in a later video. So let's go ahead and get started. So looking at our main.go file, we of course have our SQL because we're going to be using the MySQL driver. And as you can see here, we're going to go ahead and throw away that value. We're not going to have anything in this main.go file that has MySQL then data type or function. You will see it down here. This is just telling it what the name of the driver is. Now we still have to have this here, or else it's the SQL package is not going to run correctly. This package needs to use this driver, even though we don't use it directly in this main.go file. But since we do use SQL, we are going to have to have it. If you don't already have the bcrypt package, just go ahead and put go get golang.org/x/crypto/bcrypt, and that'll go ahead and bring it in for you. Now let's take a look here, and of course we have our template, our database set up. And we, of course, are setting up our connection to our database. And we're only going to have two paths here, one for /register and one /register authentication. So this first one is just going to go ahead and display our form. So if I go to register.html, it's going to go ahead and display our form. Maybe it's easier if I just show you here. And we're going to have some criteria, and of course our form's going to have our name field and our password field. And like I said, it's going to do all those checks, and if it all checks out, we'll go ahead and add it to the database, and we'll have our new user registered. And of course, when we hit the submit button, the action attribute is going to go ahead and send us on the path /register authentication. So after they put their information in the database, it's going to go ahead and go to the path register authentication. It's going to run this other handler. So like I said, this first handler, we're just printing a line so you can see which one of these is running. For instance, if I go back to here, you can see just register handler running. As we go on, we're going to have several different handlers. So this might make it a little bit easier for you to follow what's going on. Anyway, we're just taking our template and we're just executing our register.html file, and we're not passing anything in. Now, if we were passing something in, we do have a if statement here. So if we do have something we're passing in, it'll get displayed here at the bottom. Okay, so let's just go ahead and create a user real quick. And let's go with Betty. And now we have several criteria here. Regardless of what criteria you put in here, users are going to try and be fairly predictable, which is unfortunate, but we have something to help counteract some of that. Anyway, we need to make sure the username contains only letters and numbers. It's kind of nice if you want a website where they can pronounce the the actual username, that can be nice. I know some different accounts allow you to have several uppercase I's and L's and be like a barcode, or it's just some little picture made out of symbols. We want to make sure that it's only letters and numbers. So that it's just a little bit easier to read, a little easier on the eyes. And we want to make sure it's at least 4 characters, but shorter than 51, longer than 4 characters and shorter than 51. Passwords must contain uppercase, lowercase, a number, a special character. and passwords must be greater than 11 and less than 60. So I'm going to go ahead and create a really bad password. So uppercase PASSWRD 1234 question mark. All right, congrats, your account has been created. So let's take a look here. So we went ahead and when we first refreshed the page, it went ahead and just displayed our form. And then we got down here. Then after we hit submit, register.authenticate ran, which is here, which we have this handler registered to it. So if, let's take a look at register authenticate. And we're just letting it know it ran, as you can see up here, register authenticate ran. So first we showed our form, and then we made sure we could authenticate it. We parsed our form, we grabbed our username, and then we got to check to make sure it's alphanumeric. Now, if this isn't a big deal for you, you can go ahead and skip that part. But anyway, what we're doing is we're ranging through username. It's just a string. Remember, a string is just a slice of bytes. So we're going to range through each one of those. First letter was a capital P, then a lowercase a, then lowercase s, and lowercase s, and so on. So it'll run through and run this code for each one of these. So we're going to be using the Unicode package, and it has a bunch of helpful little things, little checks that we can use. So this one here in the Unicode package, we have the isLetter function, and we just pass it that character. Remember, the first letter would be capital P, so it would check and say, hey, yeah, that is a letter, so it would return true. Does true equal to false? Well, no, it's not, so it's false. So basically, we're just trying to decide is this criteria, the name alphanumeric criteria, is this true or false? Because at the end, all these different criterias, if they're not all true, then we're not going to go ahead and create a new user. We're going to go ahead and send them back. So let's take a look at that. So here's our criteria. We have our name alphanumeric, our name length, password lowercase, password uppercase, password number, special, password length, and password no spaces. And if these are all true, as we can see here, we're going to make a check. And if any of these are or statements, or operators, sorry. So if any one of these is false, we're going to go ahead and send them back to the register.html page. We're going to pass in a message saying, please check username and password criteria. So we can show that later, but basically all of these have to pass. Now, being that those are true, we're finding the opposite of that. And so if it says false, 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 false all the way down, it's not going to run this, and we'll continue into our code down here and create an account. But if any one of those is false, it'll equate to true, and then the statement will be true because these are or operators, and then we'll just send them back to the register page. Anyway, let's get back to checking for alphanumeric. So Unicode is letter. If it is a letter, it's going to return true. And if it's not equal to false, then it's going to return false. So basically, we have this and here, and we're just checking if it is a letter or if it is a number. So we want to make sure, so if it's either of these are false, then it's not going to set this to false. So if this one's false, then false is equal to false, and it's true, then this is going to be set to false, and then it's going to send the person back to the register page. So we want to make sure there's nothing but letters or numbers. So this one's check and see if it's letters, this one's check if it's numbers. So as long as it's one of those two, it's fine. Notice this and operator. But if it's a symbol or something else, it's not going to work. And we're going to go ahead and check our password length. So we use the length len, and if the length of the username is greater than or equal to 5, and so both of these have to be true, length of the username is less than or equal to 50, then name length is going to be true. One thing I forgot to mention is this one we're setting the value and we're setting it to false, but on most of these other ones, for instance, like name length, we're not setting a value right off the bat. So it's going to be its 0 value, and the 0 value for a Boolean is just going to be false. So once we create our variable, it's false, and we need to prove that, hey, yes, the length of the username falls between these two. It's not too short, not too long, and then we'll go ahead and set it to true if it's a good username length. Now, and we're going to check our password criteria as well here. So, and we just printed off the password and password length. You can see it down here. We had our password, our really bad password, and our password length. And again, our 0 value state for each one of these is going to be 0. Password, no spaces. We're actually setting that one to true. And we're going to check every character in our password to make sure there are no spaces. And if there are no spaces, we will, or if there is spaces, we'll set it to false. And then that will make sure, that one doesn't register. But anyway, so we're going to run another for loop, just like we did on a username. And we're going to range through passwords, which is just a slice of byte. So again, it's going to go through every one of the letters. So capital P, A, S, S, W, R, D, 1, 2, 3, 4, and question mark. So, and it's going to run a switch statement. And we have all these different cases here. And we want to make sure that all of these get set to true. So as it goes through the first letter, whichever of these are true, it'll set. And we need to make it, the password to qualify, we'll have to set all these criteria to true by the time it ranges through that slice of byte, that our password, once it loops through all the different letters. So if in the Unicode package is lower, if it's a lowercase letter, the second letter A, you see here, that is lowercase, so that's going to be true. We run this, and it's going to go ahead and set that criteria to true. The upper, this one satisfies off the first loop with the capital P. Is number. When it gets to the first one, it's going to go ahead and set that one to true. This one here, we want to make sure we have a number. I'm sorry, as we have a special symbol. So we're going to take any kind of punctuation or any kind of symbol. So if it is punctuation or if it is a symbol, we're going to go ahead and put password special character special set to true. And again, here was our one exception here, Unicode. If any one of these equate to true, if there is a space in there, we're going to set this to false. And so then we're going to send them back to the register page. And just like with our username, we're going to go ahead and take our password. We're going to check the length, make sure it's it's greater than 11, but less than 60. And then if it is, we're going to go ahead and set the criteria password length to true. And here we printed all of these so you can see those. So being that, as you can see, all of those were true, all of those qualified. Bring that back down. And again, we were just checking to see if all those were true, because if any one of those was false, exclamation point would turn it to true. And being that these are OR statements, any one of these is true, it's not going to register. It's going to go ahead and run this piece of code here. We're going to send them back to the register.html page, and we're just going to tell them, like, please check username and password. Now, the next thing we need to do is we need to make sure the username doesn't already exist in the database. Because if there's a user and a new user comes along and overwrites their name, they're going to be pretty infuriated. So we're going to go ahead and select user ID from bcrypt is the name of our table here. So let's just take a look at that. So here's our table, and we just have a user ID, username, and a hash. Now, we're using a hash instead of a password. We'll go over that a little bit here in just a second. So, and from our statement here, we're looking where username is equal to. And so basically, if there is that username in the database already, we're not going to go ahead and override it with a new one. db.query. So remember this returns a row, so it's going to take our statement, and it's a variadic function, so it's as many different variables we're passing in. Being we only have one question mark up here, we're just going to use the username variable, and that's going to place username, our username in there. So, and that's going to run. Remember that row is different from rows. It's not going to stay open. It's just going to grab the results and return it into row. So we don't have to use the defer close on that one. We're creating a user ID string variable, and to see if we had an error or not, we need to go ahead and run the scan method, and we're going to go ahead and place the user ID into this string while we're scanning. Now, if we want to make sure that we get the SQL dot error no rows error, if we don't, that means there's a username for this that already exists. So if our error does not equal to that, then, well, that means we have a user, and we need to make sure we send them back to the register page, and we'll let them know, hey, username is already taken. Now, if we continue down into our code, that means that it wasn't equal to error, or it was equal to SQL error no rows, which is good. That means that we don't have a username by that name, and we can go ahead and create a new user. Now we're going to go ahead and create a hash instead of a password. The short of it is people, if say all the usernames and passwords get stolen, it not only compromises your site, most users use the same passwords across multiple sites, and it puts many other websites at risk. But if you have a hash, it can be more difficult for the user to try and figure out what the password is for that hash. So you can use a hash to figure out if someone has the correct password, but since we don't actually have the password, if someone steals it, it makes it a lot harder on the criminals. Anyway, so we're going to create our hash. We're going to use the bcrypt package, and we have our function generate from password, and this takes a slice of byte, and we're going to put our password inside a slice of byte and convert to a slice of byte, and then we're going to use the bcrypt default cost. Now, the cost on this is just how difficult and how difficult this algorithm is to run. Being that hackers will create they'll test many different common passwords and see if the hash comes out the same as the hash they've stolen, and if it is, then they know the original password and they can use that to compromise that account. As hardware gets better, they can run through those hashes they can create hashes much more quickly and make more checks. By us increasing the cost just a little bit, well, we're only running that hash one time, while they're checking many possibilities. So this just makes it so we can increase that cost of running that algorithm, the time it's going to take to finish it, as hardware starts to improve over time. So this is going to make, so in the future, people are used to hash on the CPU. Now a lot of it's done on the GPU. Hardware is always getting faster. This is going to help fend that off. So you could put a larger number in there as hardware advances to help protect your site. Anyway, if we have an error creating our hash, we're going to go ahead and just send it back to register page and try and register again. Now, I'm printing these off. This is not what you want to do. This is just so we can see what's going on while we're running it here. In actuality, you would want to go ahead and log these. So that way when something goes awry, you can see what happened, where, and when. And we're printing off our hash. And this one, we're running the string function on it. So if I go down here, notice that the hash is a slice of byte. So each one of these is same as a letter. And now if I run the string on hash, as you can see here, this is what we get. Looking at let's go ahead and update this. There we go. So here is our hash, and let's take a look at this. So this is at bcrypt on Wikipedia, and how bcrypt does this, and we still have a salt. The salt is just built into the hash. So this first part here, this is which particular algorithm we're using, and here is the cost that we're incorporating in there, how difficult and how much it's going to slow down generating hashes. And then here's our salt. Now, the reason we have to, a salt is just a random sequence of letters that we're going to put on the front of their password before we hash it. Now, why would we want to do this? Well, a lot of people use the exact same password. So if you have, let's say, 10 people with the same password, say maybe it's like football or something, when football gets hashed, a hash always comes out with the same thing on the other side every single time. So passwords like football, baseball, 1, 2, 3, 4, 5, 6, whatever, those are going to be common passwords. Those are going to be in what they call a rainbow table, and the hackers are just going to look for that particular hash in those rainbow tables, and they're going to know, like, hey, that lines up with a particular password that they've hashed before. But by putting a random sequence of characters on the front of the password before we hash it, well, that's going to make it a lot more difficult for them, because that completely changes the output they get on the other side, the hash that they get. So more than likely, they're not going to have an unlimited number of rainbow tables for each one of these weird random sequences of letters, and then of course whatever the password was that create the other, that was with it to create that hash. Let's go back. Okay, so we're going to go ahead and create a statement here, and so we're going to use db.prepare, insert into the bcrypt table username and hash, and we're going to accept 2 values. Now if we run into an error, we're just going to go send back and try and register again. Remember, on these statements, this is going to tie up resources, so we need to use defer, and then our statement with its .close method. So we need to make sure that we close this and free up those resources later. And here's our SQL result. Down here, this is just to show that after we execute our query, so we remember that the query, our statement, has this built into it, and so it's just going to take our arguments, it's going to take username and hash, and those will be entered in accordingly. And so if there's an error, it's going to let us know. But anyway, it's also going to give us a result, so we can look at how many different rows affected, last inserted. I just put that in there so you can see, yes, those do exist. So rows affected 1, last inserted 5, so that's what we would expect. And the error was nil. Now if the error is nil, that is a good thing. That means that our insert went as we thought it would. So if it is not nil, something went wrong. Say error inserting new user, and we'll just execute our template again, send it back to the register page. Everything went, something went awry. Now, if everything goes as we expect, the criteria are all met, they don't have a user by that username already, and everything gets inserted correctly, then we're just going to go ahead and say, hey, congrats, your account has been successfully created. So like I said, we didn't do any email validation. I thought maybe we had enough to cover here in this first video, and we'll put that in a different video later. Let's show what happens when we put in an account that doesn't exist. Or let's show what happens if we don't follow our rules. All right, please check username and password criteria. Okay, So we ran a register handler again to display our form. Then we ran the authentication process. Our password was just the number 1, which obviously isn't going to work. We didn't have a lowercase, so that was false. We didn't have an uppercase. Password number, password special, no special character. We did have a number. No, it didn't qualify for length. At least it didn't have any spaces in it. Name alphanumeric. Well, it did have a number, so that part was true. Or I said it did have a letters, yeah. And then the name length wasn't long enough. So anyway, that's what you get when it doesn't qualify. And so in our code, right here, this was executed since we didn't, any one of these, if it's false, then it's not going to go ahead and continue executing our code. So looking back at one more thing on our database. Now, this hash here that we created with capital P for password 123 question mark, this is the same password that we used to create this hash up here. Now, notice being that the salt is different on this one versus that one, these end characters, none of these characters come out the same. By putting a random salt on the front of that, it means I'm going to get a completely different output than, now, even if I have the same password as the one I had up here. So just something to be aware of. So if the hacker was to steal this table, they might have, let's say, they might even have that one already hashed, password 123 for question mark. Being that these have different salts, they have to go ahead and try solving with these salts plugged onto the front of it. So they can't pre-hash it on a rainbow table. They just have to run it again with that particular salt, which means it's going to take them a very long time to run every single one of these. One of the reasons it's so much quicker is if they have a password table and they hash everything into one big table, it's easier for them to hold on to that table and just keep looking through all the options much quicker than, say, just executing every single possibility in that table again. So it's a trade-off for memory space, for speed, but this will make it a lot more difficult for them anyway. Like I said, we're just registering the user and this one, but we'll go into logging in, staying logged in, middleware, and hopefully eventually I will even look at validating emails as well. But if you like the video, like and subscribe, and I'll see you in the next one.